All right, in this video, we're going to go through some conceptual questions. These questions are going to involve the concept of diffraction and interference with light waves. So single slit, double slit, diffraction gratings. So as usual, answer the question on your own and then watch the solution. So here is our first question. So the correct answer is B. We can show this, our single slit interference. We have y sub p is equal to p lambda L over A, where p is a multiplier, 1, 2, 3, 4, 5, so forth. Now this equation is specifically for the dark fringes, but the bright fringes exist everywhere between these dark fringes. So here we're making the slit narrower. A is the width of the slit. So if we make that smaller, y gets bigger. And if you recall, y, we have in a single slit pattern, we have the wide, bright central maxima with smaller, not quite as bright maxima on either side. We defined y equals 0 in the center of this central maximum. So if y gets bigger, for example, y1, if y1 gets bigger, then that central maximum will be bigger. y2 being bigger means this dark spot would be farther away. So the whole pattern will be spread out over a larger distance. So these bright spots, or bright fringes, will be farther apart. Here is the next question. The correct answer is D. If we block one of the slits, then we now will only see the single slit interference pattern. So go back and watch the video demonstration if you need to. We always see the single slit interference pattern, and then within the single slit interference pattern, we see the individual bright and dark spots due to the double slit. So that double slit, when one is covered, those individual spots or alternating spots, we will no longer see, and we will only see the single slit pattern. Here is our next question. Correct answer here is A. So when we look at the two slit or double slit, whether we look at the bright fringes or dark fringes doesn't matter. We can use either one. So if I look at the equation for bright fringes, for example, y is the distance on the screen from fringe to fringe. So in the picture up here, y equals 0 is in the center, Y1 would be to the first bright spot on either side. So we're looking at making D bigger. If we increase D, then Y will get smaller. That means those bright spots will get closer together if the Y value is smaller, then the bright spots are closer. Next question. Correct answer here is C. So if you recall, light is coming from both slits. Now this is a highly exaggerated picture. If light goes to the central maximum, they travel the same distance. So the light coming from slit 1 and the light coming from slit 2 travels the same distance to get to that central maximum. For constructive interference, in general, if the difference in travel for one wave versus the other is a multiple of wavelength of lambda, then we get constructive interference. So going to this next bright spot, since that is the first bright spot after the central maximum, that would be a delta R of one single wavelength, meaning light from slit 1 is traveling exactly one wavelength farther than the light from slit 2. Similarly, if we go to this second bright spot, then the next value of M would be 2. So the extra distance traveled would be 2 wavelengths to get to that location. Our next question. The correct answer here is A. If we think about the equation that describes where we would see the bright fringes relative to the center of the central max, Y is equal to M lambda L over D. So in this case, we're only looking at changing the wavelength. Now, I don't expect you to necessarily know off the top of your head the comparison of red versus green, but we do have our little table on page 2 of our test notes that shows the very bottom, colors and light wavelengths. It shows that red is approximately 650 nanometers, green is approximately 510 nanometers. So green has a smaller wavelength. With a smaller wavelength, then Y will be smaller when we shine that through the same slits. Y being smaller means those bright spots are closer together. Okay, one last question. So the correct answer here is C. So if we think about the violet, there's going to be a certain value of y1, meaning the first bright spot. There would be a certain value of y2, y3, y4. I'm just choosing a simple one to talk about. We're going to replace this violet light with red light, which has twice the wavelength. I'm going to call this a D2. If we used the same size of slit, D, then Y2 would be double because the wavelength is double according to this question. Here, though, we want to reproduce the original pattern. So we want Y1 to equal Y2. So if we set these equal to each other, we have the red wavelength in terms of the violet. We're not changing the distance to the screen. So if we solve for D2 here, we get 2D. You might have noticed that just by plugging in the equation in general. If we double the wavelength, then we have to double D. So double that distance between the slits in order to not change that ratio.